Heat. The heat is one of the most useful forms of energy because of its direct relationship with the work. How that's come? For example, to slow an airplane after touchdown, the brakes are applied. Here we have a tire of aircraft and here we have a brake assembly. When the pads of the brake applied to the rotary disc, the kinetic energy will change from kinetic energy to heat energy. This heat energy will help the tire that touchdown to slows, and this is the benefit of the heat. Here when we look to this, the example, to slow an airplane after touchdown, the brakes are applied. When the brake is applied, the kinetic energy of the moving aircraft is changed into heat energy by what? By the brake pad friction against the disc. This mechanism will slows the wheels and produces additional friction between the wheel and the runway. So the first friction, it will be between the wheel and the disc. The second friction, it will be between the wheel and the runway. And at the last, finally, it will slow the airplane. The unit that used for measure the heat in engineering field is the BTU. BTU is British Thermal Unit, and this British Thermal Unit is a relationship between the heat and the work, and one British unit is equivalent to 778 foot-pound of works. Now we are going to talk about the types of heat. We have two types of heat. The first one is called latent heat. The latent heat is the heat that causes the change of states. How that's come? When a pan of water is left on a stove and heat energy is continually added, the water temperature rises to a peak and remains constant. Beyond this point, the water changes its state from liquid to vapor. So when this heat will change the state of water from liquid to vapor, it's called latent heat. So again, the meaning of latent heat is the heat that causes the change of state. The state means gas to liquid or liquid to gas, solid to liquid or solid to gas. This latent heat remains in the water as long as it is in its vapor form. The second type of heat is specific heat. Specific heat is the heat required to rise the temperature of 1 gram of a material 1 degree Celsius is known as materials. So we can say as the type of material when we say a gold, and the temperature of this gold is 15 Celsius. When it is raised from 15 to 20, that means that is a specific heat. But when our gold changes from gases to liquid, from solid to liquid, we will see that that is latent heat. Okay, so the specific heat of water is 1, while the specific heat of the most other materials is less than 1. And can you see that on your book on the figure 230? As we know, when a solid material is exposed to a heat, this material, it will expand. Also, when a water is exposed to a heat, the water, it will expand. How that's come when the water change from its liquid state to vapor state. So when heat energy is added to an object, the molecular movement within the object increases and the object expands in a physical dimension. This expansion, a change, is most noticeable on gases. How noticeable in gases? When we say the water change from its liquid states to gas states, we will say the water, it will be empty. In fact, the expansion of gases is so great that the expansion energy produced can be harnessed and used to do work. So the expansion on the gases, it will be more than the expansion of solid and liquid. So we can see that solids and liquid expand far less than gases. Therefore, you can determine the amount of expansion by multiplying a material original dimension by its coefficient of linear expansion. Every material has its own coefficient of linear expansion. How that's come? We can use a formula for finding the expansion of a material, and we will see it now. Here we have our formula. This our formula. The expansion is equal to K multiply L T2 minus T1. The K meaning the coefficient of expansion, the L meaning the length of the object, T2 ending temperature, T1 is the beginning temperature. To estimate the expansion of an object, it's necessary to know three things. What are these things? The first one, the object's length. So if we didn't have object length, we can calculate the expansion. Second one, the rise of temperature the object is subjected to. If we don't have the T2 or T1, we can't also calculate our expansion. The third one, the object's coefficient of expansion. If we didn't have the coefficient of expansion and this the key, that means you can't find our expansion. Transfer of heat. There are three methods by which heat is transferred from one location to another or from one substance to another. These three methods are conduction, the second one convection, the last one radiation. What's the meaning of conduction? The conduction requires a physical contact, so we need to contact between a body having a high level of heat energy and a body having a lower level of heat energy. For example, here on the engine, we have for a reciprocating engine, 4 cylinders. The heat, if there isn't contact between the cylinder and the body, the heat, it will not transferred. The second one is the convection. The convection is the process by which heat is transferred by movement of a heated fluid. That means a heat fluid will move and this heat will transfer the heat to the another or to the area that the heat will conform to it. After that, the last one, we have the radiation. The radiation is the third way heat is transferred, and it will transfer through radiation. The radiation is the only form of energy transfer that doesn't require presence of matter.